Right. Let's start the discussion of today's one. Now we are going to continue the session from the last week one, right? Okay. Can we write another example? Putha? We wrote units for some physical quantities, right? We wrote some physical quantities unit, and today we are going to take additional exercises, right? Can we write now? Example number one, write the date today. Example number one, write down. Today's first one. Okay. Like this one, right? The equation related to viscosity, the equation related to viscosity is written as follows. Write the equation. F over A equal eta delta V over D, where F is force, A is area, delta V change of velocity, D distance, D is distance. Find the unit of coefficient of viscosity. Find the units of coefficient of viscosity, bracket eta. Okay. Okay. Now you have 2 minutes to complete this one. Let's start, right? You are asked to find units of eta. Let's start. Okay, you have to do this one without seeing the last week book, right? This is repeated question. Can? Yes. Subject eta to identify the physical quantity. So this one goes up, this one comes down. Then we have F into D divided by A into delta V, right? Okay, then eta becomes kgm s minus 2 here meters divided by meter squared velocity change ms minus 1. So we have the unit of eta kg m1 m2 mn cancel, m comes up minus 1, s minus 1 is to 1 cancel s minus 1, right? To the then eta consists with this kind of unit. This is repeated one, right? Okay. Now, let's take the new part from this week. Example number, today's second one, right? Can we write second example? Okay, write down. Displacement of a moving object. Example number 2. Displacement of a moving object. Displacement of a moving object related with the following equation. Displacement related with the following equation. Can you write this one? Example number 2. S equal xt plus yt squared, where s is displacement. Where s is displacement. S is displacement. T is time. Find the units of x and y. Find the units of x and y. Right. Now you have 3 minutes to complete this one. Separately, you have to find what is the unit of x and what is the unit of y. Right. Let's start now. Right. Let's see whether enough time to complete. How? First of all, we have to consider this kind of expression, right? Here consists with positive sign. Let's see. We can write this one again. S equal xt plus yt squared, right? Okay, carefully you have to see this one. Puti, when you have this kind of expression like this, if you are asked to add 5 Newton and, very simple thing, right? 5 Newton and 3 Newton. 5 Newton and 3 Newton, final answer should be 8 Newton, right? 5 Newton and 3 Newton, simple thing, 8 Newton as well. 9 Pascal minus 5 Pascal should be 4 Pascal. Anyhow, subtraction take place with the same unit, right? And the resulted one should also be same unit. And here, 5 Newton and 3 Newton. Newton, resulted one is also Newton. Let's see another one. Here you have 2 multiplied by 5 Newton plus 3 multiplied by 2 Newton. Final answer is here 10 Newton, 6 Newton, 16 unit Newton. So, whole simplification represents Newton, whole simplification represents Newton, and the resulted one should also be Newton. What do you say now? If so, and this one too. Let's see again, another one. You are asked to add 5 Newton and 3 Pascal. If so, what is your final answer? Don't mention it, right? Okay. You have to think, imagine, right? What is the final answer for addition of 5 Newton and 3 Pascal? We can't add, no? We don't add these two. We can't add these two quantities. Why? This one represents Newton value, it's force. This one represents Pascal value, it's pressure. Force and pressure, completely two different physical quantities, they won't be added. Then what is the statement? Addition or subtraction? Addition or subtraction should be done only through the similar physical quantities. Addition or subtraction should be done only through the similar physical quantities. So, can we apply that theory for this one? That is not an equation, right? You don't add those two, right? They're not possible to add. Reason, two quantities, they're not matching. Then we can't add them. But here we have an equation here equating this and this. Then whole part of this one. Don't write, right? First of all, you have to listen carefully. Darwane, accuracy should be the built-in one, right? You have to build your accuracy by seeing carefully. We don't do any other thing when you are doing the class, right? Okay. Consideration should be the maximum one, right? This one is added with this one, right? And it is equal to another one. So, this one added with this one and the resulted one is this one. So, then you have to say this, and this should be represented same physical quantity. Same physical quantity. Isn't it, Buddha? They should have similar properties. Then you can say what? S unit-wise equal with xt. S unit-wise equal with xt, not the magnitude-wise, right? Not the magnitude-wise here. Newton, 5 Newton, 3 Newton, these two similar, not in the magnitude through the physical quantities. Then we can say S is measured by meter as it is displacement. X to be found, T time. S comes down and goes up. X becomes M, comes down, goes up, -1. Then this could be velocity. Is that clear with that? Right. As well, you can say S similar with the physical quantity represented by yt squared. So S meters, y to be found t s squared. Y becomes m, s comes down, goes up, right? So final answer is -2. So this one represents acceleration. Then this is the application of unit when we have separated the quantities with the addition or subtraction. Is that clear with that? Perfect, right. Can we manage from here? First of all, can we write a statement at the next level? Can we write the statement? Write down this. The addition or subtraction. The addition or subtraction in an equation. The addition or subtraction in an equation. The addition or subtraction in an equation should be represented similar physical quantities. Similar physical quantities. Similar physical quantities. Right, perfect. I think it's better to copy like this and write down same physical quantity each, this, and this. And separately able to write like this and this one, and separately you can manage, no? Right, perfect. Complete this one. Okay. Can we write next example now? example number. Today's third one, right? Okay. Third example. Displacement represented with the following equation. Displacement represented with the following equation. Third example. S equal v plus x divided by 2 t minus y. T minus y. Where S is displacement. Where S is displacement. S is displacement. V is velocity. T is time. V is velocity, T is time. Right. Find the units of x and y. Find the units of x and y. Right. I think 3 minutes maximally enough, right? Let's start. Time starts now. Let's start now. Right. Clear? Okay. Let's see further. No need to simplify the brackets, no? By simplifying the bracket, you can take the final answer, no matter. By simplifying the bracket, you can identify the unit of x and y. But no need to simplify this now. Why? No need to simplify this one. Reason? Let's see. Very easy, no? Why? Here, these two are subtracted. These two, until to those two, t and y are subtracted. So, subtracting physical quantities should be same. We wrote it, right? Even they are added, even though they are added or subtracted, they should have similar physical quantities, similar properties. They should be similar. What do you say? They are similar. Then here we have subtraction, t minus y. T minus y. Y subtracted from t. So both of those two exactly similar. Then t similar with y. So y should be seconds. No need to simplify. You can take the final answer by simplifying the bracket, no matter. Anyhow, that is also okay. This one is perfectly okay. Reason shortest one, no? Okay, next. This one added with this one, v plus x. V added with another function, x. V added with x and v are added, then they should be the similar quantity. These two similar, but these two similar, different kind of similar. This and this won't be equal, right? They are multiple with each other. Here then, v similar with which one to the x? Clear? Yes. Then v similar with x, then we have to say x is ms minus 1. Here seconds, here velocity. Got it? Yes, very easy, no? Yes, easy to understand, easy to identify the way, but you have to see, no? Hari පැහැදිලිව ඔයා මේක දකින්න, right? After simplifying the brackets, you can take these two answers too, no matter. But imagination, you have to manage, right? Okay, this is nice question to identify the shortest method. Clear with it? Yes, done. Can we complete? Example number 4. Okay. So can we write example number 4? Write down. Right. Write this one. Following equation shows the combination of the moving velocity of an object in a liquid. Can we write? V naught equal 2a squared g d over eta 9 eta minus 3a squared gx divided by 5 eta, where v naught velocity, a radius, g gravitational acceleration, eta coefficient of viscosity, d density. Next line. Find the units of x. Here, this is the question. Can we use 3 minutes maximum? Right. Let's start. Okay, enough time. Right, let's see. This is also a tricky question, Buddha. If you can clearly see the adjustment of the equation, you can take final answer very easily. How? Let's see. Carefully see this one and this one. So these two are subtracted now. Then these two should be similar. Then again we have 2a squared gd over 9 meter. Similar with unit wise 3a squared gx over 5 eta, right? Then you can see a squared both side available. Unit wise they are cancelled. We can cancel this and this, and g and g we can cancel. Reason, either side available. Eta cancel. Additionally, we have the letter d and letter x with the numerical values. Then numerical values are not having the units, just values. Numerical values are not having the units. This one just a value in the equation. In the equation, there are values. No units, here no and no units. Clear for the done. Then you can say this side we have density, the other side we have x. Then x should be d, density, kg m minus 3. Can you put the final answer? It's very easy, no? But we don't write like this. You just see a coupled, g coupled, eta coupled. Only rest of d and x should also be coupled. Then similar quantities. Clear with that? Like that. Copy this one. Then answer is x is density. D is density, no? Then x is density. That. Right. Question number 5. Considering fifth question. Okay. Can we write this? Frequency of a stretched string. Write this one. Frequency of a stretched string. Frequency of a stretched string related with the following equation. Related with the following equation. Can we write this one? Where here f equal capital N over 2 capital L root of capital T over capital A and rho. This is not P, this is rho, density. Where F is frequency, L is length, N number of loops on the string. Number of loops on the string. T, tension. Tension is force, right? Within bracket, force. Rho, density. Then find the units of A. The question is, find the units of A. Let's start now. 3 minutes maximally, okay, right? Okay. Today you must simplify, right? You must think about the question. Sir, board එකේ හදනකම් ඉන්න එපා හොඳේ. You have to complete before me, right? After completing, we will discuss this one. Then after that, you can identify the accuracy of the writing process. Therefore, you must complete, okay? Right, now, let's start. Okay, enough time. First of all, let's see the doubt here. You are asked to find the unit of A. Okay, A is trapped inside the square root, no? A trapped inside the square root. So what should I do? Then both sides we can square. As the needed quantity is trapped inside the square root, both sides we can square. How? Whole equation, either side square. Then f squared in n squared 2 squared 4 l squared square root cancel as squared, right? Okay, then we have t over a rho, isn't it, today? Done. Clear. F squared equal n squared over 4l squared t over a rho. Now we can take a to the other side. So we have a equate a only this side, right? We have here t n squared divided by 4l squared, present one, f comes down, we throw frequency squared. This is the subjected one from the given equation, right? Then substitution. T, tension is force is kg ms minus 2. Here we have number of loops, number, numerical value. It doesn't have unit. Number of loops. Previous question, we identified numerical values are not having the units. Then this is also the numerical value, number of loops. We have 3 pens here. What is the unit of this one? Unit, not the quantity. Unit. No unit, just 3 pens. 3, no units. Right? So, clear, right? Okay, then here no units divided by L squared. 4, numerical value, no unit. L, meter squared. Rho, kg, m minus 3. Frequency, SI unit hertz. It is derived one, basic one is S minus 1, but it has to the power of 2. Clear? Yes. Now, can we simplify now? We have kg cancellation. And here, m2 cancel with these two, then we have minus 1 available, right? From this one, is that clear? Here, m to the power of 2, m to the power minus 3, 2 of them cancel off, plus 2, minus 2 cancel, minus 1 available, it comes up, right? Then it becomes, when m minus 1 comes up, it becomes m plus 1. That m plus 1 and this m plus 1, m2. Kg cancel, it doesn't have kg value. And here, s minus 2 is to s minus 2. Here, minus 1 into 2, s minus 2. S minus 2, s minus 2 cancel. Then we have only presented one, meter squared. Then A is meter squared. A should be area. It is simplified until have the final answer. Is that clear, Buddha? Right, done. Okay. Can you complete right here? Right. Number 6. Next question now. This one clear, okay? Right. Now, one by one, we have to identify, right? Next, write down this. Rate of volume flow bracket Q related with the following equation. Q equal pi a to the power of 4 delta P over 8 eta L, where delta P pressure difference pressure difference. L is length. Eta, coefficient of viscosity. Q, rate of volume flow. Find the units of A. Find the units of A. Again, just 2 minutes enough, right? 3 minutes enough, right? Complete now. Time by time, you have to manage the answering time, right? Okay. Okay, enough time, right? Let's see now, right? Okay, then they need A now. A at here. Then subject A to the power of 4 present at here. This 3 goes up. Q into 8 eta L. Pi and delta P comes down. Delta P comes down. Okay, then A to the power of 4 represented Q. To take Q, rate of volume flow, rate, volume divided by time, rate of volume flow. Can we consider here? Rate, it is called volume divided by time, right? So, volume represents cubic meter, time represents seconds, times comes up, S minus 1, eta M kg M minus 1 S minus 1 L meters pi, no units as numerical value, delta P kg M minus 1 S minus 2. See, can we simplify now? A to the power of 4th represented kg cancel, right? Next. Meters minus 1 cancel. S minus 1 coupled together, S minus 2. Those two cancel with denominator S minus 2. See again. Kg, numerator, denominator cancel. Right. Per meter, udayata cancel. S minus 1, numerical value added S minus 2. And those two, these two and this, numerator and denominator, up and down cancel. Done. Then we can say here meter to the power of 3 available, M available. Then we have M to the power 4. Right? We can take power of 1/4 either side. Then we have A becomes meter. Then A is meter. Right? Favor the right. Copy the calculation. If you have some doubt, you have to verify, right? Okay. Okay, let's see another one. Number 7. Let's see another one, right? Okay. Right, number 7. X equal A sine BT. X equal A sine BT. X equal A sine BT, where X is displacement. T time. Find the units of A and B. Okay. If you can understand the question, then can we try it now? Right. Can we see this one for the right? This is a kind of different one, no? Why? It is, you mentioned x equal a sine bt, right? Then let's see the identification. You are given this kind of rectangular triangle, right? You are given this kind of rectangular triangle. Let this angle theta. Let this base is x, this one is y, and this one is z. Then you are going to write cos theta. Cos theta is opposite base x, adjacent base y, hypotenuse z. And you are going to write sine theta. Sine theta, opposite base x, hypotenuse z. As well, tan theta. Tan theta, opposite base x, adjacent base is y. See? All the trigonometry ratios, even though it is cos or sine or tan, they consist with distance over distance, distance over distance, distance over distance. So, what do you say? Trigonometry ratios, especially cos, sine, and tan, they are not having the units. Cos value, sine value, and tan value are not having the unit, right? It's a new point, right? Can we copy that one? Can we write? Trigonometry ratios are not having the units. Say it. Trigonometry ratios are not having the units. Example is this one. No? Here meter cancel, then cos theta, unitless. Then this one doesn't have unit, no units. So this one should be equal to this one. So you can say x similar to a. Can we say yes? Then a represented meters as x is displacement. Got it. Simplify now. One of A and B completed now. Is that clear? Right, that next. And you can say sine BT, no units, right? Then BT represents no units, unitless. Then B into T seconds, here no unit, then you can say just one. It's just a numerical value, right? Okay, as there is no any kind of value at the no unit region, just say what? Not zero. Zero is impossible value. Zero is not in use in the calculation, right? Okay, then just one. So B becomes, S goes down and comes up, S minus 1. Clear with that? Right, copy this one. Okay, then this is the way of taking this kind of answer. The question is specific, like this, with the included of trigonometry ratios, right? Then that ratio doesn't have the unit, then through that one, we have to continue. And here BT equals no unit. So no unit, don't put zero, just one, no unit, right? Then just we wrote one, as there is no unit, then S comes down and comes up. One is vanished, then S minus 1, the below unit of S comes up, then it minus 1, right? Done. Okay, Buddha, right. Now, can we write the next topic, Buddha? Now we have identified about, yes, we have identified some physical quantities, derived quantities as well. How to simplify, how they simplify. We identified that one too. Clear with it? Right. Okay, done. Okay. Before writing the topic, you have to carefully identify this one. Darune, additional two physical quantities are demonstrated. They are not included in the basic units as well as derived units, right? You are given two specific quantities. They are not included in the basic unit, basic units and derived units. They are intermediate units. Two quantities are identified. One of them is called plane angle. One of them, you are given that one, plane angle. Plane angle is this kind of angle subtended at the center like this. This is coplanar drawing one, right? This is drawn on the coplanar one, right? This is the single surface. This is drawn on that one. This angle, let it theta. This angle is called plane angle. Plane angle, right? It is this one. The Ronate plane angle is identified as supplementary physical quantity. Supplementary means this is not included with the fundamental physical quantity group as well derived physical quantity group. They are additionally identified, especially they are using by measuring the angles. SI unit of this one is not degree, and that is non-SI unit, right? SI unit of this one is called radian. SI unit of theta represented by radian. Basically, this is introduced rad. If you are given the value of plane angle 5 rad, rad is the unit, right? Okay, radian, some full term is radian, but in the symbol matter, we are introducing this one rad like this. Okay, right. This plane angle is identified as, yes, the first supplementary physical quantities. Right. Can you write the topic? We have another one too. We will discuss, right? Okay. Write the topic, supplementary physical quantities. Physical quantities. Right. Write down the introduction. Two specific physical quantities. Two specific physical quantities are demonstrated. Two specific physical quantities are demonstrated that are not included, that are not included, that are not included in the basic physical quantities, in the basic physical quantities, basic physical quantities and basic physical quantities and derived physical quantities, basic physical quantities and derived physical quantities. Therefore, Therefore, these two are introduced as these two are introduced as supplementary physical quantities. Supplementary physical quantities. Right, next line. First one, write down plane angle. Plane angle, right. Today, this is introduced arc length. This is arc length. Here to here length is radius. Basically, plane angle is written arc length divided by radius. So, if the plane angle is theta, arc length is S. Let this arc length S, radius is simple r. Then we can say arc length S over radius r is, then S becomes r theta. S equals r theta. This is used as the standard equation. This one is the combination in between arc length, which means the length on the circumference. That is also okay, right? Length on the circumference, length in the circumference length. R is the corresponding radius. Theta, subtended angle at the center. As this is drawn on the single plane, this is plane angle, right? Copy the diagram, write down this whole function until here, right? Okay, let's take. Right, finish. Number 2, solid angle. Solid angle is three-dimensional introduced. Introducing three-dimensional arrangement like this. When we consider this kind of arrangement right here, at the corner of the house like this, right? This is three-dimensional representation. Not always like this, right? This is definite shape. Corner of a house, right? But we can identify three-dimensional. This is an object. This is not the coplanar drawing diagram. This is a single plane, which means coplanar drawing diagram. But this one is three-dimensional representation. This kind of angle is identified, this angle to be measured by using a special physical quantity. This angle is called with a solid angle, right? This is solid angle. And this solid angle is measured by using the unit of stir radian. Stir radian, right? Then symbol is SR. Right? This is not in our syllabus for that, right? When you are doing engineering process, architecture in process, and if you are becoming architecture or engineer, right? In the drawing process, we are using this one, right? The building one or housing one, or we have to complete on there on a sheet, no, right? That is called the blueprint. No? In the blueprint, how to make the house, how to make the building. That procedure should be drawn, no? That is done by the architects, quantity surveyors, right? Or engineers, right? They are using that one, not in A-level syllabus, right? Okay, this is specific one, right? Write down number 2, solid angle. Can we copy this kind of one, three-dimensional one? And write down the unit stir radian, symbol SR, right? Okay, done. Okay, right, done. This is additional discussion. Okay. Then write the topic for the dimensions. Now, today we are going to start about dimensions. Dimensions. Dimensions, right? Okay. We don't write anything. First of all, you have to carefully listen about this. After that, we can manage the note, right? Let's see, Pudha. Stop all writings like this. Today, special, see three symbols. Special three symbols are introduced for the selected three quantities. One is called mass, right? Mass is introduced or mass is represented by using the symbol of L, symbol of M. Another quantity of length is introduced by using the symbol of L, capital L. And the quantity of time is represented by using the term capital T. Let's see. Mass is M, length is L, time is T. By using these three, we can manage the term velocity. The term velocity we can manage. How? Velocity is written displacement divided by time. So displacement is length, clear. Length is L. Divided by time, time is T. This one comes up, it is LT minus 1. This is called dimension of velocity. අලුත් කතාවක් නේ. This one length, this one time, t to the power minus 1. This combination is called dimension of velocity. See again, another one. You are given acceleration. Acceleration. Acceleration is written change of velocity. Change of velocity divided by short while time, right? Okay. Change of velocity is velocity. LT minus 1. Time t plus 1 comes up, it becomes LT minus 2. This is called dimension of acceleration. Dimension of acceleration. Today in physics, we have large number of physical quantities, large number of units, large number of identification. But today, when we use units, large number of units we have to by heart. Large number of units we have to identify. We have to memorize large number of units, but we have only three dimensions. We have only three dimensions, like m for mass, L for length, T for time. By using these three, we can write the dimensions of several quantities that are using in the physics syllabus. Right? Therefore, dimension, the term dimension is introduced to easy to apply or easy to identify the unknown physical quantity without using huge effect. Like this, let's see. Anywhere, right? Any kind of language book, anywhere. If you can see LT minus 1, exactly that term should be represented by velocity, right? When we use another language book, if it is having this kind of letter combination, it is represented by velocity. In units, several units we can use. How? Meters per second, centimeters per second, meters per microsecond. Different kind prefixes can be introduced. Prefixes kilo, mega, giga, tera, peta, milli, micro, nano, pico, femto, atto, like that. Several kind of prefixes, multiples and submultiples we can apply when we are writing the units, right? Several units available like Newton, Pascal, Watt, Joule, Hertz, like that. But today we have only three dimensions. Basic three dimensions are introduced for N, L, and T. By using these three, the other all the physical quantities we can manage through dimensions. Therefore, dimension is identified as the arrangement of the basic physical quantities in a given quantity. That is the definition of dimension. Say it again. This one is the dimension of velocity. This one is the dimension of acceleration. When you write volume, dimension of volume is length into width into height. 3 times of length, L cube. It is similar with unit, but with a unit, several number, plenty of number of units available. But here we have 3 dimensions. Looking through 3 dimensions, we can prepare all the other dimensions. It is easy to identify. Okay, then dimension is defined as arrangement of L to the power 1, T to the power minus 1. L to the power 1, T to the power minus 2. Arrangement of the basic physical quantities in a given quantity is called dimension. That is called the dimension. Dimension is the arrangement. How to prepare the basic physical quantities in the selected quantity. Given quantity is the dimension. Okay, right. Dimension is, it's like put a scientific notification for the trees or for the flowers or for any kind of animal. Several places, they are having several names. සමහර ගස්වලට එහෙම අපේ රටේ පවා එක එක පැතිවල නේ, they are calling different names. මේ ඕගොල්ලෝ ඕන තරම් දන්න සමහර මාළු වර්ග ඉන්නවානේ නේද? In the middle of the country, they are having one name නේද? And when we are going to දකුණු පළාතට, they are having another name, right? It's like ඌව පළාත completely different kind of name. Like that, right? හැම එකක්ම නෙමෙයි, sometimes පුතා we are using different kind of නේද? habitual names, right? ඒවා ඉතින් අර එක එක පැතිවල අනන්‍ය ලක්ෂණ ඔය කොයිද මේ අනුරාධපුරෙන් එහා පැතිවලට යද්දි they are telling completely different kind of thing අපි කවදාවත් අහලවත් නැති, right? අන්න ඒ වගේ තියෙනවා. ඉතින් then scientific notifications were introduced. The scientific notifications were introduced to easy to identify, clear identification of the things in the usage, right? Therefore, the dimension is same as like that. By using the dimensions, similar physical quantities, we can clearly identify, right? Rather than using unit. Unit also usual one, right? We can use the unit to identify physical quantity, but rather than using the units, easy to use the dimensions to identify similar quantities. Similar properties, this and that, similar property. Young's modulus and pressure, they are having similar properties. Then you can understand like that. Okay, then dimension is the suitable one, then using units, right? Can we write the introduction? Write down next line. Write down, right? Topic dimensions. Basic 3 dimensions are demonstrated. Basic 3 dimensions are demonstrated for mass, length, and time. For mass, length, and time. Right. Can we write the right side of the board? This one, mass, M, length, L, time, T. With the square bracket, right? When you are introducing the dimensions, applying the square bracket is a rule, right? Right. Next line, write down. Next line. Write the definition of dimension. Yeah. Arrangement of the basic physical quantities. Arrangement of the basic physical quantities arrangement of the basic physical quantities in a given physical quantity. Arrangement of the basic physical quantities in a given physical quantity is called dimensions. Dimensions is called dimensions. Okay. Line එකක් කරලා ලියන්න. Let's consider the dimension of. Let's consider the dimensions of the above mentioned physical quantities. Dimension of the above mentioned physical quantities. The quantities that were used, can we identify the dimensions to the here? You are given the quantities like this. First of all, write the unit, and then second of all, you have to write the dimensions, right? With the arrow, take the dimension. Before writing the dimension, apply square bracket. That's better, right? First, write the quantity, then write the unit, and then write the dimension. That will be easy, right? Okay, let's start now. We have several. Right. And we have those quantities. Use about 5 minutes. See the units. We wrote them previously. One by one, can we identify the dimension? First, write in the unit and then take the dimensions. LT minus 1, like this. Acceleration, ms minus 2, dimension LT minus 2, like that. Complete now. Okay, check in the others. Momentum, kg, ms minus 1. Dimension, m, l, t minus 1. Force, kg, ms minus 2. Dimension, mlt minus 2. Pressure, kg, m minus 1, s minus 2. Dimension, ml minus 1, t minus 2. Work and energy both same, no? Separately, it's better to write. Kg, m squared, s minus 2. Kg, m squared, s minus 2. Dimension, m, l squared, t minus 2. M, l squared, t minus 2. Power, kg, m squared, s minus 3. Dimension, m. Make a diha balagana ga. M meters L squared t minus 3. Right. First line clear. Can we complete the others too? Okay, the others, moment of force, kg m squared s minus 2, dimension, same as work energy now. Put a work energy unit, we can say joule, but moment of force, we don't say joule, it is Newton meter. But dimension of work energy and moment of force similar. M L squared T minus 2. Remember, different units of work and moment of force, but similar in dimensions. Frequency T minus 1, dimension, sorry, S minus 1, dimension T minus 1. Density M L minus 3. Young's modulus ml minus 1 t minus 2. Unit එක ලියලා ඉමුද අපි kg m minus 1 s minus 2 m l minus 1 t minus 2. Young's modulus, similar dimension with pressure. Pressure and Young's modulus same, no? Here, this and that. Coefficient of viscosity kg m minus 1 s minus 1. Dimension m l minus 1 t minus 1. Clear with that? Right. Next one. Coefficient of surface tension. Coefficient of surface tension mt minus unit kg s minus 2. Dimension mt minus 2. These are the known dimensions of the related physical quantities. Right. I think you are comfortable with the dimensions as already identified the unit, right, Putha? No doubt about writing the units. Okay, let's see. Majority, Putha, in physics, we are using the quantities in the simple mechanisms. අර අපේ physics වල අපි කතා කරනවානේ mechanical part. The physics included with mechanical parts. Then mechanical parts consist with this kind of physical quantities, especially the physical quantities related with current, related with other stuffs, electricity part. Right? We are not familiar with to write the dimensions such a physical quantity, like in current electricity. The quantity is related to current electricity, right? When we write a unit like this, let's see, a unit kg m squared s minus 2 a minus 1. A is ampere, per ampere. We don't use the dimension of ampere. Dimension for ampere value, which means current. Dimension of current available, but we don't use in our syllabus, right? In the previous years, කිසිම past paper එක අපිට ඒක mention කරලා දීලා නැහැ. Then we have to avoid them. Why? We got 7 fundamental physical quantities. Can you remember them? 7 fundamental: mass, length, time, right? First 3 we know. This and this, right? Okay. Basically, we are using those 3. Additionally, we have current, thermodynamic temperature, amount of substance, luminous intensity. The other 4 are also having the dimensions, but we don't use them. Therefore, you have to avoid the dimension of the other quantities. Clear with that? Right, done. Okay. Can we write next line to the release a line and then write down next line? Okay, say like this. Yeah. Basically, the dimensions are used only for, basically, the dimensions are used only for, main three, main three, main three, main three dimensions of, main three dimensions of the basic physical quantities. Basic physical quantity. Basic physical quantities. But the other quantities of, but the other quantities of but the other quantities of temperature, comma, temperature, comma, current, comma, current, comma, amount of substance and amount of substance and amount of substance and luminous intensity. Luminous intensity are also having the dimensions. Are also having the dimensions. But they are not practically used. But they are not practically used for the questions. But they are not practically used for the questions. Right, release one line, next line. Write down dimensions. By using the dimensions, next line, by using the dimensions, following things can be done. By using the dimensions, following things can be done. By using the dimensions, following things can be done. Right. Next line, first one. Identification of identification of the unknown physical quantity in an equation. Unknown physical quantity in an equation. Second one, number two. Identification of similar physical quantities. Identification of similar physical quantity. Similar physical quantity. Third one, identification of the validity. Identification of the validity. Identification of the validity of an equation. Validity of an equation. Next one. Derivation of an equation. Derivation of an equation. Derivation of an equation. Derivation of an equation. Derivation of an equation by using several physical quantities. By using several physical quantities. Right, clear with that? Okay. Then we have to demonstrate one by one separately what we can do by using the dimensions. Okay, right. Subtopic. It's better to write subtopic clear. Finding the dimensions and identification of similar quantities. Finding the dimensions and identification of the similar quantities. Identification of the similar quantities in the given equations. In the given equations. Right. Let's see how, right? Okay. Example number one. Example number one. Write down. Transverse wave velocity related with the following equation. Transverse wave velocity related with the following equation. Can I have this one? V equal root of T over M. Where V's velocity, T's tension, find the unit of simple M. Find the unit of M. Can we start now? Let's start. 2 minutes, enough, right? Okay, done. Okay. You asked to find M. Subject M first. M trapped in the square root, no? Then either side squared. V squared equal T over M. Take this one into this side. M is T over V square. Now, today we are going to write the dimension using the dimensions, right? Finding the dimension of M, we don't use unit. We are using the dimensions, right? You are asked to find the dimension of M, not the unit of M, right? Okay. Then we don't use unit. No more applicable of unit. If you are asked to find the dimension, use dimension. Reason, before applying the dimension, you have to put the square bracket clearly right here. Then dimension is T. Force M L T minus 2. Velocity L T minus 1 to the power of 2. Simplify this one. How? M LT minus 2 divided by L2 T minus 2. T minus 2 cancel. 1 L cancel for the power of 2. Rest of L comes up. It becomes M L minus 1. Then dimension of simple M represent M L minus 1. It's like mass divided by length. It is called mass per unit length. This is additional. Huh? No need to write this one, but to identify this kind of quantity, it's better to know this name, right? It's mass per unit length. And this is also called linear density. Linear density is mass per unit length. It is ml minus 1, right? Okay. Example number 2. Right. Example number 2. Frequency related with the following equation. Frequency related with the following equation, where f is frequency, L is length, rho is density. Rho is density. Find the dimensions of the Young's modulus, not the unit, right? Find the dimensions of the Young's modulus. Find the dimensions of the Young's modulus. This one, Young's modulus. Find the dimensions of the Young's modulus. Let it E. But today you don't take the dimension of the Young's modulus by seeing the previous note, right? Young's modulus is this one. By using this equation, you have to take the dimension of Young's modulus, right? Can we start now? Find the dimensions of the Young's modulus within bracket, put it E, right? Okay. Here E is Young's modulus. Let's start now. right? Enough time. We need this one, both sides squared. It's f squared equal 1 over 4 L squared E over rho clean. Then subject E becomes f squared 4 L squared rho. Then we have E now, right? Then next line, we are going to write the dimensions. Writing the dimensions. Here, apply the square bracket before writing the dimension. That's better, right? Okay. Substitution. F squared. Frequency t minus 1 to the power of 2. Four numerical values are not having the dimensions. L squared, L2, rho M, L minus 3. Simplifying this one. Only t we have here, M available. L2 cancel for this one. We have minus 1, ML minus 1. It's t minus 2. This is the dimension of Young's modulus. Example number 3, third one. Rate of volume flow is related with rate of volume flow is related with rate of volume flow is related with the following equation. Q equal K R to the power of 4 rho V squared eta L. Q equal K R to the power of 4 rho V squared over eta L, where Q rate of volume flow, V velocity, L length, eta coefficient of viscosity, rho density. Rho density, right? Find the dimensions of K. Can we write? Find the dimensions of K. Find the dimensions of K. Let's start now. Find the dimensions of K. Right. It's 3 minutes enough, right? Okay. Right. See now, you asked to find K, no? Subject K, then these two goes into the other side. K becomes Q into eta L divided by R to the power of 4. So the R is radius, right? It is not mentioned here, no? R is radius. R is radius. Rho V squared. Here K subjected one, rho V squared comes down. Rho V squared, right? K becomes Q. Q is rate of volume flow. Previous case, we wrote this one, no? Unit of this one, cubic meter per second. Dimensions, L3 T minus 1. L3, then apply the square bracket before writing the dimension. Like this. Then we need to find K, no? Put the square bracket for K, then the others. L3 T minus 1, eta, M L minus 1 T minus 1, L is L, divided by R to the power of 4, L to the power of 4, rho ml minus 3, V LT minus 1 to the power of 2. V velocity, no? Right. You can say, let's see, mm cancel. Finally, we don't have m, no? All the points m cancel. T, here, t minus 1, t minus 1, t minus 2. Uppercase t minus 2, lowercase also t minus 2. T to the power minus 1 twice, no? Those two cancel. We can cancel off t to the minus of t, we can cancel. Next case. You can see this and this cancel, no? Cancel. And again, if you have doubt here, L3 and here we have L4. Three of them cancel, just one available. It's the denominator. L and here L to the power 2 available. No? This one consists with L to the power 1, L to the power 2, 2 plus 1, 3, that 3 and this 3 cancel. All the values are cancelled. Then say K dimensionless or no dimensions. Dimensionless or no dimension. Dimensionless or no dimension. Can we mention it? Right. That is third example, right? Okay, let's take fourth example. We should identify the things for day by doing the sums, right? Without doing the sums, we don't exactly identify the process of the entertainment of the syllabus, right? First, we need to do more practice, right? Number 4. Write down. Velocity of a moving object. Velocity of a moving object related with the following equation. v squared equal x squared plus ys, where v is velocity, s is displacement. S is displacement. Find the dimensions of x and y. Find the dimensions of x and y. Okay, let's start now. Collaborator, accuracy to be the maintained one, right? You have to manage your calculation accuracy. Accuracy should be managed carefully, right? Okay. Okay, this is special one, no? How? As an equation, you have to say each quantity, this, and this should have same dimension, right? So we can introduce like this one added with this one added with this one to have the final answer of v squared. So dimensionally this and this should be same, right? Dimensionally this and this separately equate. So v squared dimensionally equal to x squared dimension. So x is squared cancel LT minus 1. Clear. Next. You can say v squared equal ys dimensionally. As an equation, these three dimensionally same as those two are added to have final answer of v squared. Then we have here LT minus 1 to the power of 2 equal y to be found. The quantity that is needed to find, right, presents with the square bracket. The square bracket. The others are having the dimensions, then no need to substitute the bracket. So this is 7. Then today y becomes L squared t minus 2 divided by here L squared t minus 2, no? Divided by L comes down. 1 L cancel, y becomes LT minus 2. So you can say this is acceleration. This is velocity. Clear? Right. This is next level one, right? Okay. Can we take question number 5? Next one. Okay, next, number 5. Following equation related with the displacement of an object. S equal capital A to the power of half bracket 1 plus 2as divided by v squared, where S is displacement. Both we have S here and there. V velocity. Find the dimensions of capital A and simple a. Find the dimensions of capital A and simple a. Okay, let's start now. Right. Right. Can we manage this like this? Again, S is a to the power half bracket 1 plus 2as over v square. Can we take this one into the other side? We can take the physical quantity here and there, right? According to the basic rules. S over a to the power of half is 1 plus 2as v squared, right? Then today, this is an equation, right? Then dimensionally, this and this and this to be same. Dimensionally, this and this to be same. Right? Yes, as an equation here, this one is taken into this side, then this one is the equation, then left side and right side, each function should be equal dimension. So you can say first, s over a to the power of half dimensionally equals to no dimension, just one. Then a to the power half equate L dimensionally. Dimension of S is L. A to the power half is L. Then both sides squared to cancel half power. Then A becomes L squared. Clear? Yes, done. It's very easy. Next thing, again this one. Let's see. Dimensionally this one, similar to this one. 2as over v squared. Then subject A, v squared goes into the other side. V squared over 2s. Can we simplify now? Right here. A dimensional v squared lt minus 2. It's v, no? Lt minus 1 to the power of 2 divided by 2s. 2 numerical value. It doesn't have the dimension. S is L. So we have A dimensionally L to the power of 2. L2 t to the power of minus 2 over L. Then A becomes, isn't it acceleration? T minus 2. 1 will cancel, rest of L and this one, T minus 2. A is LT minus 2. Clear? Right. This is the dimension of acceleration. Right. Done. Finished, right? Okay. Let's take another example like this. Example number 7. No? Right. Okay. Force related with the following equation. Force related with the following equation. F equal C1A plus C2V over T, where V velocity, T time, A acceleration, F force, F force. Find the dimension of the ratio C1 over C2. Find the dimensions of the ratio C1 over C2. Okay, finish. Right. F equals C1A plus C2 V over T, right? Okay. Then we can say dimensionally F similar with C1A, dimensionally C2 V over T, they are similar. Then you can say this and this similar, no? Similar dimension. C1A equate C2 V over T. Let's see the rule. Very easy. Why? Acceleration similar to V over T, velocity over time. Acceleration, left side, V over T also, velocity over time also, acceleration. No need to write the dimension. Cancel them. You can cancel them. A cancel with V over T. So, we have C1 equate with C2 dimensional. Then you are asked to find C1 over, yes, put it, C2 equal, here, no dimension. It's very easy. No need to consider this and this, find in C1. Considering this and that, find in C2. After that, getting ratio, wasting time. If you can understand here, acceleration A similar with V over T. Then simplification done. It's very easy, no? Yes. Okay, right. Can we complete the calculation?